Hey everyone, Steve Fascio, conservation biologist with the Vermont Center for Eco Studies, and with another vernal pool video. It's been about a month since I've had a chance to get out here and do another video. And here we are the day before the summer solstice. It's one of the longest days of the year, and nice early morning in June. And making a quick visit to see what's going on with these pools. We've had a gorgeous stretch of summer weather the last few weeks, which is great for us. It's been very dry, however, so any gardener would know that you've had to spend a lot of time watering. But no one is more concerned about rain than the animals that are developing in these vernal pools, the amphibians especially, that need 2 months, maybe almost 3 months of water to complete their metamorphosis and become terrestrial. And this pool has shrunk down quite a bit. And what we're going to do today is contrast two different pools that are side by side, and look at the differences between these two pools. Let's have a look. So as you can see, this pool still has a significant amount of water. This is a deep pool. When it's full, it's about 4 feet deep, and it's still probably 2 feet deep in the deepest section, maybe even a little bit more. But it has shrunk in size quite a bit, and over here you can see this area of just bare leaf litter. A month ago, that was flooded right up to the edge where you start to see the green. And now it's shrunk down significantly to a much smaller size, but still it has plenty of water volume, and this pool is what I would consider a significant pool because of that significant water volume. That even in drought years, this pool usually holds water into August, or sometimes even later into September. As the pool shrinks and the water warms, as with most aquatic breeding amphibians, the larvae develop faster as the water gets warmer. But there's also a density dependence phenomenon that's going on, where if the pool gets too small, the volume of water shrinks too much so that the density of the amphibian larvae, particularly the wood frog tadpoles, if they reach a certain threshold where they're so dense, their reproduction, their development rate actually slows down, and that is probably what controls the population of the adults, is this density dependence in very dry years or in very small pools, limiting the size of the adult population. In a pool like this, that density dependence probably is rarely reached, that threshold where their development rate is slowed down and they would metamorphose at a much smaller size when this density dependence effect occurs. And in some pools, the density of these tadpoles can be extreme, where you can have 1,000 wood frog tadpoles in just 1 cubic meter of water. So they're really competing with each other for food resources and oxygen, and that's the density dependence that is working against them. This gives you a chance to see how large and fat these tadpoles have grown to. This is a wood frog tadpole. It's about 1.25 inches in length. No legs emerging yet. Hind legs will emerge first, and then shortly before metamorphosis, the front legs will emerge, and then the tail will shrink up, and it'll be ready for terrestrial life in another, probably by mid-July. It'll be ready to leave the pool. Right now it's just an eating machine, primarily eating algae and periphyton, which is a nutrient-rich food source that's made up of algae and bacteria and phytoplankton that sort of grows on sticks and rocks and any other surfaces in the pool. And here we have a damselfly larva. And if we can see this little guy right here, this is a phantom midge larva. And then we'll contrast that large, still flooded pool with this smaller, still a good-sized pool, but significantly more shallow, and it probably has a smaller watershed to collect water from, surface water. This pool is completely dried up. This is only about 20 meters away from that other pool. So this smaller pool that dried up would have had complete reproductive failure for the three species that chose to breed in this pool instead of the one just back there, 20 or 30 meters. So Jefferson salamanders, spotted salamanders, and wood frogs that deposited their eggs in here, none of those young will survive. But of course, that's the reproductive strategy that these guys depend on. They put all their energy into depositing a lot of eggs, but no energy into parental care or raising their young. And some years they have a lot of offspring, and some years they have none. And those years tend to balance out. But this pool would be considered insignificant, or at least just an average pool, while the one just behind us here is a significant pool because of that longer period that it holds water, the longer hydro period. Well, thanks for joining me, and if I have a chance, I'll try to get back out here late summer and look for some metamorphs, some of those young wood frogs and salamanders that are just leaving the pool. See if we can find some of those. Thanks, everyone.